Hello and welcome to this project on text extraction for image. So in this project, we will be working on extracting text from images. After extracting the text, we will apply some basic functions of OpenCV on that text to enhance it and to get more accurate results. This project will be very useful and it will save time and effort of typing from an image. So let's see what are the steps involved to solve this problem or to make this project. First, I'll show you how to download Tesseract and install it with other dependencies. Tesseract is the most important Python library here. We will use it to extract the text. Second, we will load the image for which we want to do the text extraction. We will resize it and then save it. Then we will use PyTesseract to extract the text from the image. Then we will start the processing of the text extracted from the image. For complex images, we will use OpenCV for further processing of that image. Then we will remove the noise from the image using the blur function. After that, we will perform threshold transformation of the image. Then we will see how to erode image using CV2. Then we will perform some other image processing operations, and in the end we will see how we can draw rectangles around a character and a particular pattern or word. So different organizations can use this to extract useful information from the image and store it. Individuals can use it for saving their time and effort for typing. It will ease the burden of document analysis and understanding them. It will reduce man work and revolutionize the system by automating the OCR method, that is optical character recognition method for text extraction. So let's get started and create this project. So for this project, we will be using Google Colab as it provides high computational power and OpenCV requires that. In this project, we are working on extracting text from images. We will take an image from the internet which contains some text and we will try to extract that text using Tesseract. So let's start. So in the first step, we will import request which will be required to install Tesseract. The request library will fetch the URL for Git files and images. Let's run this cell and import requests. So after importing requests, we will now download Tesseract, which is a required library for PyTesseract, and save the file at the path in open function as you can see here. As we are working in Google Colab, so setting this path is really important. Otherwise, Tesseract will not work. Similarly, we are downloading Tesseract from a GitHub repository, which we are fetching using the request function. So let's run this cell and save this file in the path in open function. So in next step, we will install the required libraries for OCR, that are Tesseract. So here we are using apt install Tesseract. Similarly, we will use IPython to clear the output which is not important for us, that are undesired outputs or irrelevant outputs. So let's run this cell and install Tesseract. Here you can see that the Tesseract is being extracted and this is the output for that. It is unpacking the library that we are downloading. It will take some time. So it's finished now. As you can see that the outputs are not holded on the screen because we used clear output function of IPython. Next we will install PyTesseract and OpenCV, and we'll clear the output for this also as we don't require the installation details. So our PyTesseract and OpenCV libraries have been installed. Now let's move forward. Now we will import some of the required libraries for this project, which are: we will import image from PIL, which is used to open the image and load the image or download the image, visualize the image. Similarly, we'll use PyTesseract, which is the main library for extracting the text. We will use OpenCV, that is CV2, for image processing. We will use NumPy as it is used for mathematical computation. To hold the output, to see the output, desired output, we will import output from PyTesseract. And we'll also import RE. Let's run this cell and import all the required libraries that we want. So in order to start this project, we'll first need an image. You can take any image from the internet, copy that URL and use the request library to download that image in Google Colab. Here I am taking a random image which contains some text from the internet and fetching it using the request library and saving it using image.open function. Here you can see that I am also resizing the image so that we can visualize it better, and I am saving it after that. So now let's run this cell and visualize it, the image that we downloaded. So this is the image which contains some text. In the next step we'll see how we can extract this text. So here we can see that I am using the custom configurations with English language, and I am using pytextract.image2string function which will extract the text from the image that we have already loaded. Here we can see that we have passed the image in this function and we have set the configuration as the custom configuration. Now let's run this and see the text if it is extracted or not. So here we can see that the text from the image, from this image, it is extracted, and we can see that here. Now next we will see how to remove irrelevant symbols or characters from the extracted text. Here we are using pytextract.image2string to convert the image, to extract the image text from the image. We are using the language equal to English, and we will pass the characters to remove in a string. Here you can see that I have passed exclamation, brackets, @ all that symbols that I don't want in my text, and it will remove that. So these symbols will be replaced with an empty string. Here you can see that I am running a for loop for character in characters to remove, and the new string will replace the character by empty string and then print that new string. I have made it as an exception handling in which it will first try this, and if this not works, then it will get into exception and print the error. Now let's run this cell. So here we can see that replaced all the characters with empty spaces. Now we need to perform some OpenCV operations. So OpenCV is required when the images are complex. So now let's load the image in OpenCV. So here we have loaded the image in using OpenCV cv2.imread function. First we will convert this image to the grayscale. So converting into grayscale is important because the image becomes less complex to process, and it will have only two values, that are 0 and 1. The cv2.cvt color method, it is used to convert an image from one color space to another, and currently there are 150 color space conversion methods available in OpenCV. Let's run this cell and convert our image into grayscale. So here we can see that our image is converted into grayscale. Now let's move forward. The second step, and an important step, will be to remove the noise from the image, and generally for noise removal we use blur. So blur computes the median of all the pixels under the kernel window, and the central pixel is replaced with the median value. It is highly effective in removing noise. Let's run this cell and remove the noise from our image. So we've run this cell and removed the noise from our image. The next step would be, we'll perform the threshold transformation. So if a pixel value is greater than a threshold value, it is assigned one value, maybe white, else it is assigned another value, that is maybe black. This function is known as cv2.threshold. So the first argument is the source image, and it should be in a grayscale. So we are passing the grayscale image here in the threshold. We have created a function named thresholding, which will return the cv2.threshold of the image, and it requires a grayscale image. Let's run this cell and perform the threshold transformation here. Here you can see This is the output for threshold transformation. Next we will see erosion. So here we are doing erode transformation using the cv2.erode method. The basic idea of erosion is just like the soil erosion only. What it does is, it erodes away the boundaries of the foreground object. Always try to keep foreground in white because it will be easy for the erode function to perform transformation on it. So it is normally performed on binary images and it needs two inputs. One should be the original image and the second one is the kernel, the structuring element, which will decide the nature of the operation. So here you can see that the kernel I have chosen is a matrix of 5 by 5 which will contain 1 and the image we are passing is the gray image. So now let's run this cell and perform the erode transformation. So here you can see that this is the output for erode transformation. Next we will perform morphological transformation. It is useful in opening small holes inside the foreground objects or small white points on the object. It is defined under the cv2.morphology function. Here also we need to define a kernel. So here also I have used the kernel equal to np.ones 5 by 5 which will create a 5 cross 5 matrix of ones, and we are using the grayscale image that we have already created. Now let's run this cell and perform the morphological transformation. So this is the output for the morphological transformation. Next we will see how we can detect the edges of the image, of the text. So this is the Canny edge detection. So Canny transformation is used to detect the edges in this image. Here we are passing the image that we have already converted into grayscale, and we are using the cv2 function, that is cv2.canny. Let's run this cell, find the edges on the image. So this is the output for the Canny edge detection. Next we will work on skew correction. So de-skewing is a process whereby skew is removed by rotating an image by the same amount as its skew, but it should be in the different direction. So this results in a horizontally and vertically aligned image where text runs across the page rather than at an angle. Here you can see that I have created chords which is np.columnStack, where np.where image should be greater than 0. I am using the cv2.min area rectangle and passing the chords in it. So if the angle is less than -45, then the angle will be equal to 90 plus angle but with a negative sign, that is the opposite direction. Else the angle will be negative of the current angle size. We are finding the height and width using the image.shape and storing it into h and w respectively. Similarly, we are finding the center of the image by dividing the width and height by 2. Then we will rotate this, and for rotation we are using the cv2.getRotationMatrix2D function and passing the center and the angle to it. Then we have created a rotated variable in which we are calling the function cv2.warpAffine and we are passing the image here, and this function will return the rotated image. Here you can see that I am calling the dskew function on our gray image and it will return me the rotated one. Now let's run this cell and see how it performs. So this is the deskewing operation that we performed on our image. This is the output for that. Next we will do template matching. So template matching is nothing. In this we just try to match the image. We are passing same image for matching, so we got a similarity of 99%. But if we use different images, it will find the location of a template image in a larger image. So if we need to find an image inside any other image which is a bigger image, so we can use template matching. OpenCV comes with a function cv2.matchTemplate for this purpose. It simply slides the template image over the input image as in 2D convolution and it compares the template and patch of input image under the template image. So here you can see that in cv2.match template, I am passing the image and the template file. Now let's run this cell and see how it works. So it gives me a 99.9% similarity because we are passing same images for both image and template. Now let's see how to create rectangle around the text, and this is used to segregate every character in the text by creating a rectangle around it. So in this we are using the image.shape to find the height, width and center of the image. Similarly, we will use the function pytesseract.image2boxes. After that, we are running a for loop which will split the words, and we will use the cv2 function, that is cv2.rectangle, which will create a bounding rectangle, which will create a rectangle around each word. Now let's run this and see how it works. So here you can see in the output that it creates rectangle around each and every word here. As you can clearly observe, each and every character is bounded by a rectangle here. Similarly, we can draw patterns on specific words. We can draw rectangles on specific pattern or word. For this, we will pass a pattern that we need to make rectangle on, and we will run the for loop which will match the pattern in the text, and as it matches the pattern, it will create a rectangle using the cv2.rectangle function, and it will return the image. Let's run this and see how it happens. So here you can see that we choose the pattern as artificially, so it found artificially in the text and create a rectangle around it. Similarly, we can draw rectangle around specific words or patterns. With this, we came to an end of this Google Colab notebook. We started with learning how to install Tesseract, which is used for text extraction. Next, we took an image and extracted the text from that image, and we learned that we need to use certain image transformation function of OpenCV in order to extract text from complex images. So the scope of this is that different organizations can use this to extract useful information from the images and store it. Similarly, individuals can use it for saving their time and effort of typing. Next, I will show you how to create a Flask app for this. So let's move forward. So in order to create a Flask app, we need to create a folder with OCR app name, or you can choose any name. This is optical character recognition app, so I am taking this name. And I have created certain files which are required for the Flask app. Let me explain you each one of them. So first we will see the config.file. In this I have imported OS, and from OS I have taken environment. Here we are defining the configuration. So for the first class, that is config, we are setting debug equal to false and testing also false. Similarly, we are setting the file path in the base dir variable. We have chosen a secret key by a PyAnalytics name. You can choose any secret key, and you should provide the uploads folder path, that is in the static folder. Here you can see static folder in the uploads variable. Also, we have set session cookie secure equal to true and default theme equal to none. Other than this, I have created two more classes. One is development config, in which I have set debug equal to true and secure equal to false, and one more class, that is debug config, in which I have set debug equal to false. Now let's see the app.py file. So this is the main file which will run the app. So if the main function will be called, it will run the app. Running the app is done through init.py. So let's see what is init.py. So in init.py we have imported Flask, and we have set the app equal to Flask name, and we are calling the configurations here. As we have already defined the configuration in config.py, we are calling them here, and we are also importing views from app. So let's see what's the views.py file. So this is the main file that we have created. I have shown you this code in Google Colab. This is the exact same code. Let me explain you one more time. So this is all the required libraries we need to import. I have already explained you all of in the Google Colab. Here we are setting the file path for the uploads in initial file upload config. we are setting the path to config. So in the app.root, we have two methods, get and post. By default, it will be get in the initial phase, so that it will open the index.html file the first time the app is launched. And as soon as we create or execute any request, it will be in the post section. In the post section, you can see that I have taken the image using image upload request.files. Similarly, I have opened it using image.open and performed all the operations that we have already seen in Google Colab. All these operations are similar, exactly same to what we have done in the Google Colab. Converting the image to array, then image to grayscale, then converting image back to PNG, extracting the text from the image, removing the symbols, and all the functions that we have already explored. Here we are again saving the image to display in the HTML, and then we are returning the image. In the end, you can see this is the main function. So whenever the main function is called, the app will run. Now let me show you how I designed the front end. This is the index.html file. So in index.html file, I have created the front end of the app. In order to understand this, in order to get a better knowledge about this, you should already have a basic understanding of HTML and CSS. Here you can see that I have used jQuery and also materialize.css. So I have imported both. Next, in the first division, I have created the heading of the app, that is optical character recognition app, and also made by PyAnalytics. In this second division, I have set the option for the user to upload the image and a button named with browse. So the user can select the browse button and upload any image that he wants, from which we will extract the text. In the next division, I have defined the scripts which will handle all the data that is being uploaded above and perform the required operations that are needed in order to extract the text from that image. Other than these files, some of the files are also important in the static folder. In static, you can see that I have created certain folders. First is the CSS. So I already told you that we are using materialize.css. So it should be in the CSS folder along with materialize.min.css. This is the image section. So the white background image that we use in the app, it will be stored in this. Similarly, in the JS folder, I have used materialize.js and materialize.min.js. And the uploads folder will contain the uploaded image by the user. Some of the most important files that are required for this project are procfile. So procfile will tell that this is a web app, and it will run the command Gunicon, which will in turn run the app with a timeout of 60. That is a time lapse of 60 seconds for the app to run. Now let's see how it will work, how we can run this app. And before running, we need to satisfy all the requirements. So here you can see I have created a requirements.txt file. So these are all the requirements that are necessary for this app. You can create this requirements.txt. Let me show you how you can create this. So here you can see that I have opened Anaconda command prompt. You need to move to the specified folder where your project is saved. So you should copy that location and type it here. I am using cd space, the location of my folder. So in order to install the requirements.txt to create that file, you need to run this command pip reqs here, and it will create the requirements.txt file here. In case pip request is not installed on a system, you can easily install it using pip install pip reqs. As we installed any library using pip, similarly pip reqs can also be written by this. So here you can see that my requirement is already satisfied because I have the requirement.txt file is already there. So here in the project folder, I have also created a readme file. So in order to make this project work, we need to do some installations. Before that, we should install Tesseract on our machine. I've copied this link here. You can go to this link, copy this link and paste it in your browser. Here on this link, you should download this according to your Windows version, whether it is 64-bit or 32-bit. I have already downloaded it. You need to download this and install this. This is a exe file. It will easily install. And after installation, you need to set the path of this. So let me show you how you can set the path. For that, you need to go into the C drive. Let me show you how you can do that. So in your C drive, you need to go to the program files. And if after installation, your Tesseract OCR will be seen here, you need to click on this and copy this path from here. You need to copy this path, go to the properties of this PC. Here, you should go to Advanced System Settings. So in the Advanced System Properties, System Settings, you will see this Environment Variables tab. You need to click on this. So in the Environment Variables tab, you should go to the path, edit this and add your path here. I have already added it, as you can see here. In this path variable, you can set your path and add it and click on OK. So there's one more important step that you need to do before running this app. So here you can see that we have created the requirements file. Now you need to install all these requirements in your system so that this app runs perfectly. So for that, you need to run the command pip install -r requirements.txt. This will install all the requirements that are mentioned in your requirements.txt file. Here you can see that it is installing all the libraries that were mentioned in my requirements.txt file, and it has completed. Now we'll see how we can run this app. So as we are already in the app folder, we just need to run the main app file. So for that, we need to run the command python app.py. And we'll run this. So it is showing us that the app is running on this path. I copied this path and now we'll go to the browser and check whether the app is running correctly or not. So here you can see that I have copied the path that it was showing me, and this is our app, the optical character recognition app made by PyAnalytics as defined in the index.html. Now let us see if it is running fine or not. We'll browse and select an image. You can select any image, but in order to get a correct result, you should select an image which should have some text. So I'm taking this image, opening it, and let us extract the text from this image. So here you can see that this is the image and this is how we extracted the text from this image. With this, we came to the end of this project. I hope you liked it. It is really easy. I showed you each and every step, how you can create the Flask app, how you need to install the dependencies, how to create the proc file, all the requirements, how to satisfy those requirements, and how to run this app in the end. Thank you.